Awesome. Welcome to the IC Realtime webinar series. Again, I am Pat Carter. I'm the technical trainer here at IC Realtime. I handle all of our public as well as private webinars. If you're interested in hosting a webinar for your team, feel free to reach out to me. I am Patrick at icrealtime.com. Today we're going to talk about networking and connectivity, and this is a real important webinar for our new installers and for our existing installers. You can always pick up a trick or two here. We're going to talk about encoding, about making the best use of your throughput that you have on your network connection, and we're also going to talk about networking in general. This is kind of part of a back-to-back series. On Friday, we will be doing a webinar specifically on wireless. I will have Rob Henry, who's our wireless specialist, join us. Let me dismiss this. Sorry about that. I will have Rob Henry joining us on Friday. Again, we will be recording that webinar, so definitely if you can't make it on Friday at 10 a.m. or 4 p.m. Eastern Time, feel free to keep an eye out for that on our YouTube page or on icrealtime.com. So today, again, we're going to talk about physical connectivity. On Friday, we're going to talk about wireless connectivity. And between the two webinars, you guys are going to be 100% up to speed on any type of connectivity you need to do. So let's move this out of the way. First thing I'm going to do is actually bring up a PowerPoint slide. I have a PowerPoint that I use in my technical training. I'm going to be utilizing that here. Let me launch this. Let me go to a full view from current slide. And this is actually one of the important things that installers really should know. And so these are the keys to successful installation. Obviously, the very first step of any project, even before you quote the job, is coordinate with the client's IT staff. Find out who it is that manages the infrastructure, who's responsible for the network. If it's a residential job, it's probably you. If it's a commercial job, maybe they have an outside vendor. They often refer to those as VARs or value-added resellers who manage the network. Maybe they have an internal IT staff or an IT manager who handles the network. Maybe it's the owner's kid who's away at college. Somebody understands that network. Somebody built it and designed it. The IP structure, the IP addresses that are being used, all kind of hopefully have a rhyme or reason. And this is very important. The IT staff will be able to help you coordinate exactly what ports need to be forwarded in the router. They'll help you with that. Our IT guys will give you passwords to routers. There's a lot of really good information in there. Of course, you know, IC Realtime offers a free service to set up the network for you, but without that admin password or without that router password, they're not going to be able to get very far. So always coordinate with those guys from the very, very start. It really is the key to a successful install. Don't unplug what you don't know. A lot of times you'll get into a data center or maybe just a switch and you see that there's a plug and no light on. Maybe you assume that there's just nothing there. That could just be somebody who's away on vacation, and boy, will they be upset when you unplug their network connection when they get back. So also keep an eye out for dead ports. A lot of switches and routers and hubs have dead ports on them. A good IT manager will put a little piece of tape over that port so it doesn't get reused. Know that every now and then you'll get the case where you'll plug in your recorder to the switch. You don't get illumination. You don't get a green light or a yellow light. You start troubleshooting the wire and then realize it's a bad port on the switch. As soon as you plug that switch in, if your recorder is already powered up and plugged in as well, you should see a green light right away. You should see a yellow light flickering right away. If you don't, just try another port. Finally, never reset a router. That's an absolute last-ditch effort. We have no choice at all. I've had a lot of installers that are out there, and while I'm talking to them, they go, oh, yeah, I don't know what the password is. Give me a second. And before I can stop them, they've already pushed the little button in on the back and reset the router back to factory. Even in residential or commercial applications, this is definitely something you want to avoid. You want to avoid resetting a router because you never really know what other rules are in there. Maybe you're doing a restaurant and it just so happens that all their credit card authorizations and all their point of sale systems go through that router as well. And they may have a set of specific rules set up that are now gone because you blew out the router or reset the router. Also in home applications, a lot of times ports are forwarded to gaming systems, for example, or maybe they're forwarded to an AV system. Once you reset that router, those rules are gone, and you got to rebuild them. You've got to figure out what they were and how they're working. Maybe we have to call the point of sale vendor back in to reset up. It's a real nightmare. So don't just haphazardly reset a router. When we talk about media, obviously we're talking about Siamese cable in the AV the analog in the AVS world, and we're talking about IP cameras. We're talking about Cat 5 or Cat 6. So the differences between those are pretty impressive. A Cat 5 cable is perfect for 1 or 2 megapixel cameras. If you're going higher than that, I would always use a Cat 6. There is Cat 5e, which is more of an enhanced version. That'll get you a little better range, a little better throughput. On most of these systems, we're looking to range out to 100 meters or about 325 feet. Cat 6a is a little shorter than that. You're closer to about 250 feet. But know that when we're talking about IP infrastructure, you're primarily using Category 5 or Category 6 cabling. Now I'm going to skip the rules down below. A lot of those, if you're kind of in the business, are self-explanatory. Be familiar with the rules. Know that the National Electrical Code and the NFPA do have specific rules regarding what it is that we do. Like I say, I just wanted to bring this slide up real quick before we got started, so you can kind of check that out. Are there any questions about this before I move on? Cool. Well, then let's get this out of the way, and let's move right to our recorder. I've logged into an NVR. I've got an NVR on my local network. So basically what I've done is plugged it into the network, and this is what I should see. Now, getting an IP address is pretty simple. You can do that through either DHCP, which means it asks the router for an available address, and the router will give that to them, to the recorder. You can do that through the IT staff. Ask them what IP address they'd like to use for your recorder, or, of course, if you don't have that scenario, you could certainly try to figure out what the network addresses are. You can check the address of the PC that you're near and just grab an address that's further out of the range from there. If I go into setup, we're going to go down and take a quick look at the networking here. Now, this particular device has multiple network cards in it. This actually is an 8128. It has 4 network cards. You'll notice that each one has its own unique local IP address. The advantage of units with multiple network cards is basically for traffic shaping. It gives you the ability to load balance. You can put the same amount of cameras on each card, and you're not kind of overwhelming one card or another. We do have several recorders with 2 network cards built into them, like our N series, for example, and that's perfect. Again, you can use that for load balancing. When you go into your network settings, you'll be able to modify that. So again, if I'm using DHCP, let me go in and edit this. You'll see that there's an option for DHCP right here. If I were to select DHCP, it would, again, ask the router for an address, and it would give you a network address. Because I'm using statically assigned addresses, meaning I know what the addresses are and I'm just adding them in, I can just select static. And I can do that for my cameras as well. If I have IP cameras, I can DHCP or static them as well. So the local IP address, and we know this is a local IP address by the numbers, 192.168 is a traditional beginning to a local IP address, meaning an address that's used on the inside of the network. So if I were to go to the internet and search for 192.168, it wouldn't find it. There's so many 192.168s, but inside your local network, that's just fine. You may also find 10.0 as a local IP address. In fact, Mac uses those quite a bit. So if you're looking at an IP address and you see that it begins with 192 or 10, the chances are very, very good that you're looking at a local IP address. So local IP addresses are great for viewing locally. In fact, I'm logged into this unit on my local network. I'm able to see it locally, but there's some other things that I'll have to do to see it remotely. So again, here's my local IP address, my subnet mask, which is universal. It's the same across all of my devices on the local network, and then my gateway. Gateway is a very important address to know. Again, if you're using DHCP, it's going to automatically assign the gateway. It'll know what the gateway is. If your IT staff is helping out, they'll tell you what the gateway is. And of course, if you're looking at other computers, just use the same gateway they are. What the gateway is essentially is that direction that all the computers on the inside use to get to the outside. That's your front door, basically, from the inside of the network to go outside. This is also the local address of your router. So if you're logging into your router interface to make changes or to do your port forwarding, this is the address you're going to use to go into it. So if I were to open up a new tab and go to 192.168.1.1, I would be prompted for the password to get into my router. So again, the gateway address is used by all the devices on the inside of your network to get outside. Are there any questions about IP before I move on? Cool. So let's go ahead and close that out. Let's talk about ports for a second. One of the things that makes IC Realtime very unique is that we do lock down our ports. We make sure our ports are very secure. We don't just leave every port open for hacking and viruses. We're not sending IP streams back to Beijing. We're not doing anything like that. We lock down all of our ports. The 3 ports that you really need to be concerned with are your TCP port, which in this case is 3 and 4 sevens, your UDP port, which is 3 sevens and an 8, and your HTTP port. Now, traditionally, your HTTP port is 80. That's called an assumed port, meaning that if I go to an internet page, traditionally I'm going to port 80. If I only have one recorder on my network, I can use 80 if nothing else is using it. If you're in a corporate network, a lot of times their webmail server will be on 80, or their file server, file sharing programs will be on port 80. So you'll have to use a different port. Now in the HTTP world, if you use a different port, real simple, you just hit colon and whatever that port is at the end of the address. So for example, I'm using port 88 for this particular device. I know I've got a lot of other devices here using HTTP. This particular device happens to be 88. So if I'm logging in from Internet Explorer, Google Chrome, Mozilla Firefox, or Safari, I would have to put in the address that I'm going to and colon 88. This is also very helpful if you have multiple recorders on one network. We get the question a lot. People say, well, what if I've got 4 NVRs? How do I know which one to go to, or how do I direct to each one? The key is to create a separate HTTP, TCP, and UDP port for each device. If I go to HTTP port 81, I would go to device number 1. If I go to 82, I would go to device number 2, and so on. So this is really helpful, again, when you're logging into multiple recorders or want to log into a specific recorder when maybe port 80 is being used. The TCP port is used mainly by our phone app and our smart ICRSS. This is very helpful if we've set up our device to be viewed remotely. Say, for example, I have an IP camera that I want to record somewhere else. I would want to give it a unique TCP address, and when I set up my router, I will route my traffic to that particular port. Now, UDP is primarily used on large corporate networks. It's referred to as the top-heavy protocol. It's very, very secure. We don't normally use it in residential or light commercial, but occasionally you will run into a case in a corporate environment where they use UDP. Now, as a good rule of thumb, when I set up my routers and I do my port forwarding, I'm going to use the UDP port as well. Now, I'm going to take you out to a couple of cool websites now that we've talked about ports. The first one that I want to take you to is portforward.com. So portforward.com is a great website. It's the ancient secret that we use in-house. People call us all the time with very unique routers, very strange routers, routers that no one has ever seen before, and we find them in portforward.com. I look at my list of routers. It'll show me all of the router manufacturers. I could even jump, say I want to go to Linksys, a very common router. Linksys is right here. I skip their ad, and then it gives me a list of all of their model numbers. So I can look at the back of the router. I can see exactly what model number I'm working with. A couple of older ones are here. Let's see if we can find a newer one. WRT is a good one. Try a 54. Once I go to it, I can go to my default guide, and it will give me a basic setup guide for that particular router. It will give me the admin password and the username. I can go into it. It will show me exactly what I'm looking for. Most Linksys routers, it's under applications and gaming is where our port forwarding rules are. So as I go down to here, it'll show me exactly what to do. I will create 3 rules, one for HTTP, going from port 80 to 80, and then directing it directly to my recorder address. I would do one for TCP and one for UDP as well. In creating rules, basically what we're doing is we're creating a tunnel in the router so that when I come in from the outside on, say, port 88, it will only route me to the NVR or the DVR in that case. It's very important to know that a forwarding rule is very, very secure. If I come in on port 3 and 47s on my phone, it's going to take me to a page where I can log in. It's going to take me right to the login page. It's very, very secured. If you have an IT manager who says, "Oh, I don't like putting cameras on my network, all their routers are open, or all the ports on the recorders are open," let them know. IC Realtime does things differently. We lock down all of our ports, and we require forwarding rules. Again, our IT staff here can help you with this. You can make an appointment. Just shoot them an email, tech@icrealtime.com, and say, "Hey, I'm doing a router setup or a new installation. Call my guy back at this number at this time," and their phone will ring. It's a very, very cool service that IC Realtime offers. So again, here is our, let me close some of these out. So here is a basic forwarding rule. Here's a basic overview. And again, portforward.com is a great, great location for that. Another really cool tool that we use a lot of is CanYouSeeMe.org. CanYouSeeMe.org, if you're on the location where the client is, my mouse to work with me, here you go. If you're at the location, this is what you would use to test your port forwarding rules. So first and foremost, it gives you the public IP address. I can see now what my outside address is. This is the address that's given to the client by their internet service provider. They maintain these addresses and they would assign it to that router so that it can be seen on the internet. I could put in my port, say port 80, for example. I know for certain that port 80 is not forwarded on our network. So when I check it, after I've done my forwarding rules, it's going to come back and say, nope, no luck. And there it is, error, could not see your service. So basically it tried to go through port 80, 80 was blocked, and it didn't, it just letting me know that it can't work. Let's go to 3 and 47s. 3 and 47s I know is forwarded, working properly. It will check it, and it will give me a success. This is how, when you're on site, you can test to make sure your port forwarding rules are working properly. You don't have to worry about any other tools that are out there or testing it with your phone. You can go right to CanYouSeeMe.org, and that will help you to determine exactly that your port forwarding is correct. Are there any questions about networking or port forwarding before I move on to Encode? Cool. All right, so let's go down here and let's talk about encoding. So encoding, excuse me here, back up here, encoding. So encoding is what you do at the recorder or the camera level to make the most of poor internet connectivity. You have 2 streams of encoding in the IC Realtime devices. So in our cameras, as well as our NVRs, DVRs, you have a main stream, which is this one here on the left. This is what actually writes to your hard drive. This is what determines how much room you're going to use on your hard drive for storage. And then you have a substream. Substream is what's streaming out to your phone app. It's what's streaming out to the web interface. It gives you that ability to use a much, much lower resolution when you're connecting remotely. So in this example, this is a great example of this. I have 1080p resolution at 20 frames per second at a bit rate of about 8 megs. That's an awful lot if I'm streaming it through a DSL modem or an ADSL modem. But on the local network, that's giving me some amazing image quality and also using up quite a bit of space on my hard drive. If I'm looking at this remotely, I can log in through my substream, looking at D1 resolution at 7 frames at 1 meg. Again, if I'm looking at this on my Android or my Apple device, a little box is going to seem like a little box. And D1 resolution looks just fine. Mainly when I'm checking the cameras remotely, I'm looking for a strange vehicle in the driveway or my front door open. I can certainly see that with D1 resolution. If there ever is an incident, I could certainly log in through the web interface, log in through Internet Explorer like I've done here, and be able to go in and do playback at mainstream. Another thing that's very important to note when we talk about settings here, of course we know resolution, we understand 1080p versus 4K versus 720p, but frame rate is something that I get a lot of questions on. So what is Real time. What is a real-time frame rate? A real-time frame rate is roughly around 15 to 18 frames per second. So your television at home, 15 to 18 frames. Folks walking around an office building, moving around is roughly 15 to 18 frames per second. So why do we even have the ability to go all the way up to 30 frames per second? That's because sometimes life moves a little faster than just folks walking around. So if you have a parking lot, or you're looking at cars driving by, or you have a case where people are moving very, very fast, 30 frames per second is certainly more what you need to do. The impact of changing between 15 frames and 30 frames is pretty substantial in your storage. So you may actually need to add almost twice as much hard drive to cover 30 frames as you would need for, say, 20 frames or 15 frames. So this is very important to note. Again, if I'm looking at just an office area, I'm looking at a house, maybe covering a small area, 15 frames is normally just fine. If I'm looking out onto a parking lot, I may want to go up to 20 frames or 30 frames to be able to cover that properly. If not, what will happen is you'll have kind of a choppy image. Maybe a vehicle will be here 1 second and gone the next. That's when you know your frame rate is set too low. Another thing that's important is bit rate. Bitrate does have an impact on your resolution. It has a big impact on exactly what your resolution is going to look like at the camera level. Know that the recorder and the cameras default at a very high bitrate. In this case, 8 megabits is really not too bad for a local network, but we know it's going to really choke out your DSL modem. So it's important to know your bitrate changes. Bitrate changes can definitely be saved in groups. You see it can go all the way down to 1024 or 768 if you need to. You can also customize it if you like. But be very careful when you're customizing bitrate because, again, this has a direct impact on your video resolution. So if I'm looking at a very grainy image, I may have my bitrate set way too low, and I'll want to bump it up a little bit. Also, keep in mind that all of our devices have network cards that are gigabit strength. So we can work in a very, very fast, if you're working with fiber or working with air fiber or working with gigabit switches, IC Realtime works very, very well in that application. Again, in the substream, you're able to lower this. So if you're working with a very small type bandwidth, working with a DSL or an ADSL, you can certainly customize this as well because, again, we're not really impacting our view that much. One other thing I want to mention about encoding before we move on is that there are separate streams within the streams. So if I'm looking at mainstream, I can do regular, like normal recording. I can set it to motion and have different resolution on motion or different resolution on alarm. So this is really handy when I'm having a basic view where I want to look at a small frame rate, but when motion happens, I want to bump that resolution up. I want to bump that bit rate up, bump my frame rate up. I can certainly do that. And the same for alarm states. If I'm doing alarm recording, recording only when an alarm contact is triggered, I could record at a much, much higher resolution during that state than what I'm looking at traditionally. Are there any questions about encoding? Encoding is a very important part about configuration and networking. Cool. Wow. Well, if there aren't any questions, let me go ahead and wrap it up a little bit. Welcome again. Thank you for taking the time out of your day to learn a little bit more about networking and connectivity. Again, I am Patrick Carter. My email is patrick@icrealtime.com. If you're interested in hosting a webinar for your team, be it technical or salesy or somewhere in between, I'm more than happy to accommodate that. We talked a little bit today about networking and connectivity. We talked about IP addresses, local versus public. We talked about port forwarding, creating those rules inside your router. And then we talked about encoding, making the most out of your resolution for very, very good quality recording, as well as having the ability to work through a very slow internet connectivity. We talked about a couple of great websites. Portforward.com is awesome. If you're working with a router, you want to do it on your own, definitely start out there. And of course, canyouseeme.org, which is a great test site. Remember again that our technical support group is here for you. They do an awful lot of networking work, and they're more than happy to set up your routers or your firewalls for you. The golden rule is always include the IT staff when you can. Make sure those guys are in the loop. They know what you're trying to accomplish. They will definitely be a huge asset to you, or they could definitely be a real pain in your butt if you don't coordinate with them. So again, thank you very much for joining us today. Friday, we will have our wireless webinar again at 10 and 4. We will be doing this webinar again this afternoon at 4 o'clock. If you have any colleagues that missed out, please have them join us. And again, thank you very much for joining us today.
Thank you.
Thank you.